So here we are. We've done step 1, step 2. Basically, we've just regurgitated this with a 1 in there and a k in there. We want to prove it's true for k plus 1. So let me give myself a little bit more space. I want to see that. So step 3. Show true for n equals k plus 1. All right, so that would be 1 plus 2 times 1/2, and I'm not going to write all this garbage out, but I do want to write in the kth term, which is k times 1 over 2 to the k minus 1. And then I want to throw in the k plus 1 term. And k plus 1 minus 1 is just going to be k. So k plus 1 minus 1. I think we're all comfortable with the fact that that'll just be k. All right, so now we want to prove that that equals 4 minus k plus 1 plus 2 over 2 to the k plus 1 minus 1. Now, I manipulated the left side right here, but I can only work on one side at a time, so I can't manipulate the right side. Although tempting to write k plus 3 right here and 2 to the k right there, but we can't do that. You can only work on one side at a time. That's just mathematicians being mathematicians. Okay. So, first step is use your assumption step. What does that equal to? 4 minus what? From step 2. Right? Pretty good so far. We assumed it in step 2. Right? That's our assumption step. So since we proved it true for n equals 1, we can assume it's true for this general case n equals k. If we can prove it true for the next term, then we can prove it all the way down the line for every number greater than or equal to 1. Okay, so I got that plus this. Okay, let me pause it. Okay, I haven't done this problem in a couple of days, but I think that this is a good idea. I could write this term right here as k plus 2 times 1/2 to the k minus 1. Do you agree? Because isn't 1 to the k minus 1 just 1 anyways? Okay. Let's see if we can do some work on that. Okay. Oh, I think. What if I factored out a 1/2 to the k? 1/2 to the, or 1/2 to the k minus 1. Let's see what that does. Let's leave the 4 alone as we had before. Let's factor out a 1/2 to the k minus 1 and see what happens here. Well, what would we get in the first one here? If I factor out a 1/2 to the k minus 1, I'd get k plus 2. If I factored out a 1/2 to the k minus 1 over here, I would get k plus 1 over 2. Oops, I don't like that. Okay. Yeah, if we just did that. Why? Okay. You see here, like we couldn't manipulate the side, but we could say that that is 2 to the k, right? Okay. Yeah, that's a good snipe there. Okay, so this right here should be a negative. Good catch. If I'm distributing that negative. Okay, so, well, this might be worth something. Let's get a common denominator here by doing that. What would that give us? That'd give us 2K. That'd give us 2K plus 4 over 2 minus K plus 1 over 2. Which, if we simplified that, would be K plus 3 over 2. Is that right? Yeah. That'd be K plus 3 over 2. Are you guys with me on that algebra there? Okay, I think this is going to lead us to where we want to be. So I'm just going to drag this stuff with. I'm going to bring this 1/2 K minus 1 and 4 minus that along with. And if I brought this out, that'd be another 1/2, right? Which would make that 1/2. What would I do with the K minus 1 here and the 1 right here? Add them. So I get 1/2 to the K times, looks like K plus 3. Now remember, from above, I want 4 minus, doesn't this look like K plus 3? Yeah, and doesn't this look like 2 to the K? Cha. So I'm going to combine these. I'm going to take the 4, and I'm going to bring that 1/2, and I'm going to multiply it through. 1 to the K is just 1, so this would be K plus 3 over 2 to the K. And I can easily manipulate that to be plus 1 minus 1. And I can easily manipulate K plus 3 to be K plus 1 plus 2. And it looks like we're done. Right? That's pretty nasty. Jacob and Wyatt, thanks for finding that negative there, whoever did it.
It was Jacob. I just said it loud.
Okay. So since n equals 1 is true and n equals K plus 1 is true, then this is true for all n greater than or equal to 1 by math induction.